Hello and welcome to this TT Electronics podcast. My name is Josh Slater, Marketing Manager for the Power Electronics Division, and I'm here with Rob Coleman, Technical Sales Manager, also for the Power Electronics Division. And today we're really excited to introduce New Space Electronics. So to start off with, let's work our way back and take a look at where TT have come from in terms of supplying to space and what we've historically done. So Rob, I know you've been around a bit longer than I. Maybe you can tell everyone about TT's experiences in space.
Just a little longer than yourself, Josh. Yeah, it may surprise you to know, Josh, that we go back to the mid-1970s on the Voyager program, where we produced product for the Voyager program. That's probably 20 years before you were born, isn't it?
That was 20 years, yeah.
And then we've moved on to pretty prestigious programs in the last few years of Rosetta, Juno and Cassini. Rosetta going out and landing on a comet, Cassini running through the rings of Saturn, and Juno obviously exploring the foundations of life on Jupiter. So we have a very good pedigree.
Okay, so as you can see on screen here, you've kind of talked about the stuff that we've supplied into geostationary orbit and deep space typically. What are the main differences in between supplying into that sort of atmosphere and then supplying into the low Earth orbit atmosphere, which we see on the left?
Well, the products used in geostationary orbit and the deep space probes are working in very harsh radiation tolerant environments. Where the life of the program is for 20 years. Typically, these missions are run by government organisations and space agencies, etc. And consequently, they have to assure that the product is going to be fit for purpose for those 20 years. So they've prescribed a very long and laborious test regime that ends up adding cost to it.
So in New Space, that's going to be, I would guess, a quarter of the size it is, so 3, 4, 5 year duration life cycle.
Yeah, as you say, 3 to 5 years is typically what's being quoted at the moment. In a much lower orbit, so the radiation issues are not so great. But a lot smaller satellites as well. Typically, the satellites in GEO will be the size of a bus. In comparison, the ones in LEO orbits in the New Space arena are going to be little CubeSats and NanoSats, often the size not much bigger than a shoebox.
Yeah. Okay, so we know a little bit more about some of the parts that are going into New Space and what's expected of them in that environment. In terms of what sort of applications there are in that atmosphere, how are people, kind of the everyday person, going to notice perhaps a change due to some of the applications of the constellations?
One of the things that New Space is sort of talking about at the moment is space tourism. So in not so many years you'll be able to book your flight to orbit the Earth in your local travel agency. But we're a little way off from that at the moment, so more practical things that will happen. We have a growing population on the planet, and it's getting more and more difficult to feed everybody. So these LEO New Space satellites will be able to monitor crops at a localized level and advise the farmer when to put extra fertilizer on to maximize his yields on food, and hence be in a better position to feed everybody in the world. So that's just one application. Another application, I think probably dear to all of our arts, is traffic management. How many times when we're driving into work in the morning we're stuck at traffic lights? It takes time up, but more importantly, it produces a lot of pollution, and we've seen the effects in major cities like London and New York, etc., where they're taking actions to ban vehicles from going into these centres because of those populations. Now, in the New Space arena, we'll be able to look at where the traffic is building up, where pollution is occurring with the cars and the vehicles in there, and then control the traffic lights to reroute the traffic so that we haven't got the congestions. and you'll be able to leave home 10 minutes later and still get to work on time, Josh.
So reduced CO2 and a reduced commute, win-win all round by the sounds of it.
Yeah, it's a pretty good situation. So lots of things like that, and in 30 years time, our lives will be totally different to today. We will be a lot of these satellite systems will be controlling our day-to-day life.
Yeah. Okay, so we now know a little bit more about some of the applications we're supplying into, but I'm right in thinking that also needed in New Space and low Earth orbit is a bit of a cleanup operation, if you like, and kind of touching on Kessler syndrome. Maybe you can tell us a bit more about that.
Yeah, yes, we can. Then at the end of last year, the reported number of satellites in the sky was 4,600 and something, of which only 1,500 were actually active. Now that's a lot of space junk up there orbiting the planet. Of course, you mentioned Professor Kessler there. He's put his name to a syndrome where a billiard ball effect, where one piece of debris hits another piece of debris and causes damage, but also causes more debris, and eventually it's a domino effect. And we've already seen active satellites and space stations that are affected by this. Did you see the picture from Tim Peake, the astronaut, of the window screen?
Yeah.
Quite amazing. If anybody hasn't had a look at it, I would recommend that you go on and read about it. It's a 7mm crack in the window screen, and more importantly, it was actually damaged by a fleck of paint less than 1,000th of a millimetre. The damage is occurring, and it's not going to be long before we see major damage.
Obviously, we've seen some of the consequences as well in New Space and low Earth orbit, but we've also seen in the news, didn't we, at the start of this year, debris falling back down to Earth, plummeting back down to Earth. It was UK and Peru, wasn't it, that were hit?
Yeah, this was from the Russian, or reported to be the Russian SL-25 rocket that broke up in re-entry. Parts fell in the north of the UK, but then 3 very large cylinders believed to be the fuel tanks from the rocket landed in Peru. Now fortunately it was in a completely uninhabited areas where it landed.
Yeah, very lucky.
Imagine what would have happened if that had hit a major city or a skyscraper or something. We could have had a major disaster and many lives lost.
Okay, so the challenges for the people building these satellite manufacturers then, what are the main things they're trying to tackle?
Well, taking a step backwards from what we've just said, these satellites that we're now looking at a few thousand satellites being put up in the near future, and this Kessler syndrome affecting it, and more debris being about. So internationally there's been a lot of agreements and now regulations that have been agreed that all satellites that are put up into the LEO space orbit or deeper space units must be able to be decommissioned successfully and safely. So we now need survivable systems within the spacecraft that says after 3 years they can put it back into Earth through the atmosphere and burn it up, and have none of this debris floating about.
So proven reliability and size of componentry as well seem absolutely critical to what the design engineers are going to be faced with.
Well, I think if you going back to the thought that the satellite is the size of a shoebox, then it is very important that shoebox has the maximum amount of electronics in there, and then size is very important, as is the weight. So we have some pretty unique solutions within TT that offer those sort of opportunities to customers.
Okay, great. Go on then, tell us all about them. I believe I'm right in saying we've got all the solutions, so I can't wait to hear about them.
Well, for a start, we should say that under New Space we will be offering a range of discrete components which are very similar to what has been in classical space. Some notable extras there. We've had a very successful introduction of silicon carbide devices into ion thrusters on geostationary satellites. So that is something we've added as a standard part now within the New Space range. But the one that I think is more interesting is our multi-chip array technology. The multi-chip array technology, I think you were still probably a tiny baby when they were put into space originally back in 1996. And we've had notable successes on programs like Galileo, FOC, and other systems, Altica and SWAT and various other satellites. However, we've always offered these as a fully customable unit. The customer would come along and show us a circuit, and we would then produce a part that was fitting for his needs. Now, this has been very successful, but it does limit the opportunities for engineers to try the product. So what we've decided, and we can announce today, is that we've decided to do a standard range of MCAs, multi-chip arrays, where we can take standard configurations and produce these for the customers as a ready-made part. So, for example, putting 8 bipolar transistors in a common emitter array. Now the MCAs, as I said before, they give us a real opportunity to miniaturize circuits, giving us reduced PCB real estate usage, delivering lower weight, mass, and at the same time increasing the reliability of the equivalent discrete solution.
That sounds expensive, maybe.
If you'd like to write a large check, Josh, we'll gladly accept it. No, the reality is that these MCAs will reduce the cost significantly over their discrete equivalents.
Okay. So, in terms of the screening levels that people designing these satellites in low Earth orbit are likely to need, where do we come in terms of that?
Yeah, well, the national space agencies across the world have been very prescriptive about all the tests that you need, really basing it on the geostationary orbit satellites. We believe at TT that for these low Earth orbits, short duration missions, some of these tests are redundant. They just add cost to it for no real benefit. So what we've come up with is a pick and mix arrangement, a bit like when you was a tiny child, you probably went to the Swedish store and picked a few sweets of each variety and then quickly went home and ate them all. We're using the same approach on the screening options. We're giving you a list of screening options that you can choose from that will meet your mission requirements. Not that is prescribed by the space agencies, but something you actually need. Now, one problem with this, Josh, is that a little bit of the engineers are a little bit frightened to go out there alone and just pick the tests you think you need. So we've come up with 2 reference specifications, baseline specifications called New Space 1 and 2, that will give him a start to knowing what tests that he may want to choose.
But they're not fixed, are they? Then?
No, not fixed at all. They're reference specs only. They are there to give a guidance. We think that the specs that we've come up with will fit probably 90% of the customer needs, but there is always going to be ones that we can't contemplate. So we can add on a day-to-day basis, we can add additional lines for the specs. Of course, if the customer's got a real demanding specification, then we can always revert back to the traditional MIL standard or ESA standard.
I've got a nagging thought in my brain that there's going to be a lot of people out there saying, can I just get away with a COTS solution effectively? And I feel like I need to ask that exact same question.
I think it's a very good question, and yes, commercial COTS product is very, very good and very reliable. However, the transistors used for consumer applications like your phones and your hi-fi systems and that often have a production life, an obsolescent life of less than 2 years. They are made on commercial lines for the consumer applications, where the first thought is really one of low cost. What we're proposing with our parts is to give you something with traceability, with pedigree, with flight heritage, and manufactured on the high rail lines that we would produce our normal geostationary parts on. So you will be assured that if you're building 2,000 satellites, the quality will be consistent across those 2,000 satellites.
Yeah.
One other thing I could add to that is the commercial parts are often made in 2 or 3 wafer fabs across the world. They can have different dimensions on the chips. What we will be doing is using a traceable die back to the original wafer fab, so fully traceable. And I think we're unique.
That's a key point, isn't it?
I think we're unique in the marketplace, offering that advantage. The proof of the pudding is trying us, as they say, but it would be nice to hear a few questions from people listening to this podcast.
Absolutely.
And perhaps a few suggestions. We want to be the partner of choice, and the only way we can be true partners is if the customers come on to us and suggest improvements to our basic idea, or tell us the difficulties they've got. So I would welcome a lot of emails. I know you're going to send out the email addresses for both of us.
Well, it's called New Space for a reason. It's effectively uncharted territory, so it's new to everybody.
Yeah, it's exactly new, uncharted territory. I believe when we look back in 20 years, or should I say when you look back in 20 years, I shall be long retired by then. We will show that TT have been a significant player into reducing the cost of space exploration and accelerating the time for these wonderful new systems we've got.
Brilliant. I look forward to it. Okay, so on behalf of Rob and I'd like to thank you all very much for listening and watching this podcast. Hope it's been pretty informative for you and thought-provoking as well. I'd more than encourage anyone interested in the New Space range, our New Space Electronics range, to drop an email or a call to the information you can see on the screen now. Thank you very much again for your time, and look out for our next exciting podcast later in the year.